problem number 1, they're asking us to find out what values will make the graphs intersect, and that really just means that we want to set the equations equal to each other. So we're going to set f and g equal to each other, and it's going to say that the square root of 4x minus 35 should be equal to the absolute value of x minus 8. So we need to go back and think about what does absolute value mean when we're trying to solve equations. So let's just do a simple one. If I said something like the absolute value of x is equal to 5, I'm really asking the question, what could I plug in here that will give me a 5? And there's two answers. There's a positive 5 could go into this space, or a negative 5 could go into this space. Right? And so when I come over to this problem, I'm really asking the same questions. I'm saying, what could I plug in here so that I would get this answer out? And the answer is positive or negative of whatever's on the other side. So here I had a positive 5, and I said, well, it could be positive 5 or it could be negative 5 in this space. And so I'm going to do the same thing on this side. I'm going to say it's possible that I'm going to have just regular square root of 4x minus 35. Right? This is the positive version, right? Nothing out front is equal to, and if you notice what happened on the left is the absolute value bars went away, so I'm going to make the absolute value bars go away in our problem as well. The other possibility, here's my or, is I'm going to say, well, maybe it's the negative number, right? So that's what we did over here. We said instead of the absolute value bars, I got rid of those, but on the other side, I made it negative. So I'm going to say the negative square root of 4x minus 35, and that's going to equal negative 8. Or x minus 8. Okay, so I'm going to get rid of this so we have a little bit of space to work here. And so what you're going to find out that happens in this problem is I'm saying what was in the absolute value bars could be equal to the positive or negative version of the other side of the equation. That's how absolute value works, right? So now when I look at this, I'm going to have to work on two separate problems, right? So let's just start with the one on the left. And it says, okay, square root of 4x minus 35 equals x minus 8. Well, we solve this by squaring both sides. If I square away the square root sign, that means I also need to square the other side. So the left-hand side is going to become 4x minus 35 is equal to, I need to square this, which remember means x minus 8 times x minus 8, which is x squared minus 16x plus 64. Okay, and then to solve this, I need to set it equal to 0. So I'm going to subtract the 4x and add the 35 over to the right. So it's going to say 0 equals x squared minus 20x. And when I add a 35, it looks like I'm going to get 99. Okay, so now I need to solve this and figure out what multiplies to positive 99 that also adds up to negative 20. And the answer is x minus 11 and x minus 9. Okay, so that equals 0. And I'm going to get two answers out of this. I'm going to get an 11 and I'm going to get a 9. Okay, and so I'm going to pause really quick on these, and I'm going to say these are my answers. Right. Let's just go take a look at the other one real quick. So the other one, I have to really do the same thing. I need to go here and say square this, okay? And I need to square the whole right-hand side, okay? So here's what actually ends up happening here. When I square the left-hand side of this equation, I'm going to actually have to, remember there's like, oh, this is actually negative 1. I'm going to square negative 1. Well, let's think about what the square of negative 1 is. Well, that's negative 1 squared. Well, that would just be 1, right? So it's 1 times, and when I square the square root, I'm going to get 4x minus 35, okay? And when I square the right-hand side, I'm going to get the same thing as my first problem, x squared minus 16x plus 64, right? And so if you notice, I don't really need to do 1 time, so let's get rid of that, right? I'm going to make this go away, because I don't need to do 1 times something. That's just exactly what I started with. And if you notice now, what happens is that at this step, the problems are identical, right? The negative sign didn't actually make any difference because on my squaring step, I squared away the negative sign, and now I have identical problems. So I don't need to do this problem because I'm going to go through all the exact same steps, and I'm going to get an 11 and a 9 again because I'm doing the exact same problem again. So the absolute value really didn't play a big role. It's actually the exact same problem as if I were just dealing with the square root without the absolute value sign, right? Here's where the little catch is. Here's where the absolute value does make a difference, okay? So let me go back to my problem right here at this step, okay? If I were to check 11, right, to see if I have any extraneous solutions at this step, if I plug in an 11 here, I get 11 minus 8, which is 3, okay? And if I plug in on the left-hand side, I get 44 minus 35, which is the square root of 9, and that is also 3. So we're good, right? That works, okay? If I check the, however, if I check the other answer, the 9, okay, let's see what happens. okay, if I check 9, I get 9 times 4, which is 36 minus 35, and 9 minus 8. That also works. We're good, right? So if I check both of these answers, 11 and 9, neither of them is extraneous, okay? They're both good, okay? However, there might be a problem, right, where I got a negative on this side and a positive on this side, and that's where we had our extraneous answers. Okay? Because, however, this is in the absolute value symbol, this one's going to become positive, right? Where the original problem had absolute value bars. So if I got an extraneous answer, I would actually say, you know what? We're still okay because I'm going to turn this one positive, and on the left-hand side, this one's positive, and so we're still going to get an okay answer. So really what the absolute value symbol does in this problem that we have to watch out for is it might make an answer that was extraneous in this second step, and it won't be because I'm going to make the left and the right-hand side the same. So just be careful with that. This one, even if I got a negative on the right and a positive on the left, in the original problem I wouldn't, and so I would say not extraneous. Right? So this problem looks a little bit more complex than it is. It's really just solving a radical problem. Okay? Problem number 3. They are asking us to write an equation, which they're calling g of x, and that represents a transformation on the parent function, and the parent function is the square root of x. And they're telling us what they want the new function g of x to look like. We're going to take the parent function f of x, and we're going to go to the right by 3, up by 1, and reflect over the x-axis. So the right by 3 is when c is equal to 3. Okay? Up by 1 is when d is equal to 1. And a reflection over the x-axis is when a is equal to -1. -1 does the reflection parts in a. Okay? So I'm going to take my function, and if you remember the standard form for transformations, we said it's a, and then whatever the function is, okay, and I have d on the outside, and inside of the function I have b, and I have x minus c. Okay? So this is what our standard form for any transformation looks like. So for us, we do have an a value. It's -1. Okay? This f with these parentheses, the big ones, okay, is actually all going to go away, and we're going to replace it with the parent function, which for us is square rooting. So f and the parentheses go away, and I'm going to put a big square root symbol, okay? And inside of that function, the square root symbol, I'm going to put b, x, and c. Well, I don't have a b value, so I'm not going to have to worry about that. So I really just have to do x minus c, which for us is x minus 3. Okay? And on the outside, I'm going to put d, so plus 1. So this is what I'm claiming g of x is. G of x is the transformation. There's a, there's c, and there's d, and I input the actual function that we started with, which was square rooting. So this is the answer. G of x is negative, which if you don't want to put the -1, we can get rid of that and just say negative square root of x minus 3 plus 1. Okay? Problem number 5 is asking about average rate of change, and I put problem 6 here so you can see both forms of it. Okay, problem number 5 is asking us to use a table. They generated the f of x table for us, and they're saying what is the average rate of change over -2 to +4. So we're going to say that the x values, remember for average rate of change, we're just going to say y2 minus on the top, y2 minus y1. Okay, so we'll say y2 minus y1, and on the bottom we have x2 minus x1, and they're telling us that the intervals for x are -2 and 4, so I'm going to say this is really for us -2 minus 4, and in the numerator I'm going to put the output values that go with each of these input values. So I'm going to say the output for -2 is 3, and the output for 4 is 10, so I'm going to do 3 minus 10. So this one looks like -7 over -6, which I can cancel out the negative signs and say a little bit more simply, right, that it is 7, okay, over 6. And that would be my final answer for 5. Problem number 6 with g of x is the same thing, with the exception that when I plug in, I'm gonna have to plug in to get my output values. Like this one, they just gave us the values. Here I actually have to do the work. So for this one, I'm gonna say, okay, on the denominator is still x2 minus x1, so 0 minus 7. Okay, and in the numerator, when I plug in a 0 here for x, it looks like I'm going to get 0 minus, 0 plus 2. So this is the square root of 2 minus, and then when I plug in a 7, I'm going to get 16, right? The square root of 16. Okay, so if I simplify this, the square root of 2 does not simplify. Okay, so I'm going to leave that one alone. This just turns into 4, so it's minus 4 over -7, and I could leave this as my answer. I'm going to just do one extra little thing, and I'm just going to take the negative out of the denominator. That's kind of standard, and I'm going to say just the whole fraction is going to become negative square root of 2 minus 4 over 7, right? So if you left them in either form, they're fine. I like this one, and so I'm going to say my final answer is that number, right? Which isn't as nice because it's got a radical, but that is the complete correct answer. Okay? Problem number 7 is asking us to write equivalent forms, equivalent simplified radicals for each of these fraction exponent problems, rational exponents. Remember, so the idea here is the denominator for the fraction in both of these is 4, and that would be the index of the radical. So I'm going to make the denominators go away, and I'm going to turn that into an index 4 radical. And so I'm just going to leave the numerators x cubed and y to the 1, which I'm not going to write. Letter B is the same thing, except before I can put them under one radical, I need to make sure that the denominators are the same. So instead of 1/2, I'm going to turn this into 3/6. And now I can put them under the same radical. So it's r to the third power and t to the third power, all under a radical with an index of 6. And I can do the same thing with the last one. Letter C is going to be a q. Right? If I make this into, it looks like 2/6. Right? That would be the denominator of 6 version of 1/3. I would say it looks like it's got to be q squared and n to the 5th, all again with an index of 6. Okay? So your last problem, I'm sorry, we have 2 more. Okay, problem number 8 for this video is again asking us to solve. This is actually very similar to problem number 1, except without the radical now. I don't have to, without the absolute value. So I can just add this step right here, square and square. And so the left-hand side will look like x squared plus 8x plus 16. And the right-hand side, squaring away the radical, will just make it go away, and I end up with 3x plus 40. Okay? And I have to solve, so I'm going to subtract the stuff on the left over to the right, so it's set equal to 0. X squared plus 5x, and when I do 40 minus 16, I get minus 24, right? And this equals 0. And this also factors. This is an x plus 8 and an x minus 3. And I'm going to get 2 solutions, so it looks like x equals negative 8 and x equals 3. But let's go back and check that in our original problem. So let's get rid of all this extra stuff. When I plug in a negative 8 here, I'm going to get negative 4. When I plug in a negative 8 here, I do not get negative 4, right? If I plug in negative 8, I get negative 24 plus 16. This is the square root of 16, which is positive 4. So I'm going to say this side says negative 4, this side says positive 4. That is not true. Negative 8 goes away. If you check the positive 3, you do get 7 on the left and 7 on the right. So this one is good, right? So just be careful. There are extraneous solutions sometimes, okay? So our last problem for this video, the end of the first page, okay, is problem number 10, which is asking us to take a look at the graph on the left, which they're calling f, right? So f is the graph, okay? So that's this one right here. And then g is the table, which is all this information. And they're asking us to do g of 3 minus f of negative 1. Well, g of 3 is going to come from the table, and g of 3 is going to come, what is the output when g is 3? So instead of writing g of 3, I'm going to say, well, negative 1 is what the g function is when x is 3. And I'm going to go to the left-hand function, and I'm going to say, what is the f function? What is the output of the f function when x is negative 1? Well, if I go over to negative 1, it looks like I go down to negative 3. So the output here is negative 3. So negative 1 minus negative 3 is just 2. So that would be my answer to that one. Problem number, or letter B, same concept. I'm going to say, let's go to the f function when x is 4, and the output, it looks like, is negative 1. Okay? And if I go to the g function, which is in the table, and I go to 1, it looks like the output is negative 3. Okay? So this looks like negative 4. Okay? And then the last one, it says, for which values does f of x equal g of x? So I actually have to look at each of these. I can check, in this case, negative 3 up to 2. So the x value here is negative 3, the y value is 2. If I come to the table, the same thing's happening. When the x value is negative 3, the y value is 2. So I'm going to say when x equals negative 3, these have the same output values. So I'm just going to check the other ones. At negative 2 in the f function, I have a 0. And in the y function, I have a 1. That's not equal. In the f function, when I have a negative 1, my output's negative 3. And it's not negative 3 over here, so that's not true. At 0, I have a negative 2. And I have the same thing happening over here, so that's another good x value. And x is 0, the outputs are the same. 1 is 0, here 1 is not 0. 2, my output is 1. 2, my output is negative 2, that's not true. 3, my output is 0. 3, my output is negative 1. I don't need to check 4 because there's no 4 on this function. So I'd say these two values, when x is negative 3 and when x is 0, both of these functions have the exact same output in this case, -3 has a 2 output in both of them. And when x is 0, my y value is -2 for both of the functions.